Hi everybody, it's Brandine here. This is a video to support Lab 6. So in this video, we are going to test some transistors to see whether they're good, but also we will then test some other transistors to see what the lead connections are, which leads are base, collector, and emitter, based on what we understand of the readings we should get when we test a transistor. So the first transistors, we will test whether we get what they expect, if they're good or not. And then the others, we will take the measurements and you'll figure out what leads are which. So to do that, I'm going to turn on my multimeter here. I've got leads in the volt, the red lead in the volt ohm connection, the black lead in the common. I'm going to set it to the ohm scale on the diode test setting, on the diode test range. Okay, so that's this setting here. And we're going to take some measurements. So I've got a little table here in view. We're going to test two transistors. Now I've got some higher power transistors here. I'm going to move them off to the side. That's for the second part. For the first part, we are looking at these two low power transistors, okay? One of them is an NPN and one of them is a PNP. So let me actually read the numbers on these and put them in the right spot. Okay, so this is the 4124, that is the NPN, and this is the PNP. And so the model that we're using, and remember, we know this model is not actually how a transistor works, but it's a good model for checking whether a transistor is good or not, is thinking of it as back-to-back diodes. So we know if we forward bias the leads one way versus the other way, we should see conducting in one direction and non-conducting in the other. So let's see if we see that. And I'm actually going to go ahead and fill in this first table for you so that you can see the results clearly, and then you'll record that in your own lab and think about it. I want you to take the readings and follow along and record them, but I'm going to write them down so that we can talk about them. And then for the next part, where we're figuring out the leads of these other transistors, I'm not going to write anything down. You have to take the readings yourself. Okay, so let's do this part of the lab. So we're going to do the first column of the table. That's the 2N4124 NPN transistor, and the legs of these transistors are labeled like this. So we've got collector base emitter when they're lying flat on the table like that. When you're using them in your circuit, if they're on your breadboard, when you're looking down from the top with the flat side like this, if this is the top, looking down, you've got collector, base, emitter. And I like to think of it that way because that fits with the picture when I draw the transistor, that I've got collector, base, emitter going down, right? So usually I think of it this way, as if I'm looking down at the top of the transistor and it's stuck in my breadboard. Right now they're lying flat on the desk, so I'll angle it so that it matches our little picture here, and we have collector, base, emitter going down like so. So the first thing I'm going to do is I'm going to spread the legs a little bit wider so that I can connect my meter leads without having them touch. I don't actually recommend you do this because the leads were nicely spaced to fit in a breadboard, and now I've ruined that, but that's okay. I'm going to take some measurements here. So I'm going to put base, which is the middle lead, positive, and I'll just clip right on there, and I'm going to put negative to the collector. So Okay, I've got negative on collector, positive on base, and I am getting a conducting reading on my multimeter. Okay, that's the conducting reading. Remember, if it's open, it's going to show the 1 dot. So that is a conducting reading. And so I'm going to write here on in my table. Okay. And going down this column, I'm now going to put the negative lead onto the emitter. And my alligator leads are a little bit warped, so they're not holding on very well. I'm just holding these leads apart so they don't touch. And you can see from base to emitter, I also have a conducting reading. Okay, so now let's flip these around. I'm going to put negative on the base. I'm going to leave that there. Okay, and okay, and I'm going to put positive to collector. I've got positive to collector, and I'm seeing that that is an off reading. I've got a 1 dot, which is not conducting. And then I'm going to move that positive over to the emitter, and I've got the same thing. So in my table, that is going to be off and off. Okay, so the last 2 readings is between collector and emitter. So first, I've got emitter negative, collector positive, and that is open, and then which is the off reading. And then if I reverse them, collector negative, emitter positive, I have the same thing. So let me write that in the table. I know it's a bit hard to see what I'm doing with my hands in the way. So that was also off and off, right? So when we think about that in terms of our diagram, when I had the positive on the base and I was having a plus minus polarity like this across this diode, that read on. When I reversed it, it read off, and that made sense. And same thing here. When I had plus minus, it read on. When I reversed that and had minus plus, it read off, and that made sense. And from C to E, either direction, because it's back-to-back diodes, getting an off reading makes sense. So this makes perfect sense for the NPN transistor. Okay, and that allows us to see that you know, we've got the direction that will show conduction, which is from the base to the other 2 leads, and then the other leads should show not conducting. Okay, so I've bent my poor little NPN back into shape. I don't want to bend the legs too much. If I bend them too much, they're going to break. Let's take a look at the PNP. And remember, for the PNP configuration, the diode arrangement analogy, the diodes are backwards, right? So let me take those measurements. I'm not going to write them down in the table there. That's what you're going to do. So I did it for the first one for you, but you're going to take the PNP readings, record them in your table. I'll take the readings. You'll record them in the table, and we'll see what you come up with. Okay. So first, I'm just going to ease the legs apart. Okay, there we are. And it's flat on the table. So I've got collector, base, emitter. And what I think I'll do is I will tape down the transistor so that it doesn't wiggle around on me this time, and then I can take the readings very quickly for you. So I have a 6-year-old, so notice that I have some very happy narwhal and rainbow tape there that is going to help us hold down that transistor. Remember, we've got collector, base, emitter. So I'm going to write that right on here. It's collector on this side, emitter on this side, and we've got base in the middle. Okay, collector, base, emitter. Okay, so let's take those readings. You can see the multimeter on the screen there. I am going to go down the list of the table there and put the leads in the right polarity. So first I need base positive, collector negative. So there's the reading, base positive, collector negative. I'm going to leave base positive and I'm going to go to emitter negative. So there's base positive, emitter negative. Now I'm going to go collector positive, base negative. Okay. Hang on a sec, my connection's a little wobbly. There is collector positive, base negative. And then we're going to do emitter positive, base negative. Okay, wait for the reading. My leads are a little bit shaky here. There's the reading, emitter positive, base negative. Okay, and now we're going to do collector positive, emitter negative. Okay, collector positive, emitter negative. And when I reverse it, collector negative and emitter positive, that last row, emitter positive, collector negative, there is your reading. Okay, so that is for the PNP transistor. Okay, so with those readings that you have now, you have enough to finish this table in step 2 of your lab, right? So that takes care of our low power transistors there. So I'm going to take this this table away, but before I do, just remember, you know, when we're giving positive polarity here and negative there, that gives us a forward bias condition, right? That gave us on. And the same thing, if we had positive here and negative there, that gave us forward biased, and that gave us an on. Everything else gave us an off. Okay, so so just keep that in mind as we test these other transistors. Okay, so I'm going to take that diagram away, and I'm going to put in now this table. So this table is not given in your lab book, right? I just made this table up myself because what we're doing now is we're looking at 2 different transistors. So we've got this case style, and these are the same transistors but different case styles. They're both 3055s, but we've got 2 different case styles. Okay, and I've got them here, the 2 different case styles. Okay, so we are going to now measure these. I've labeled 1, 2, 3 and 1, 2, 3, but the 1, 2, and 3 don't necessarily match up specifically with base, collector, emitter. I haven't kept it consistent. I've just labeled them 1, 2, 3 for the purpose of filling in the table. And then you have to figure out, based on the readings we get for each of the transistors, because remember my numbering was different each time, which leads are actually the base, the collector, and the emitter. Okay, now your lab does give you a clue that for this style of case, the middle lead is the collector, which is connected to the sink on top, and that for this style, the actual case is the collector. Okay, so we have been given that hint. And before we get into these measurements, you know, this style of case is easy. I can put it flat on the desk and angle it there, and I can see 1, 2, 3, just like I've labeled it at the top. For the other one, you know, on first glance, it's like, well, which of these legs is 1 and which is 2, right? I've labeled the case as 3, but on first glance, it's like, well, which is 1 and which is 2? If you look at this case, notice that these legs are actually closer to this side of the transistor. And on my diagram, that's this side of the transistor, okay? So if I want to be measuring these correctly, according to my diagram, I would be holding the transistor like this, where lead 1 is closer to the page, and lead 2 is up here, okay? So so I'm gonna have to make sure I hold it like that when I'm taking the measurements to match the drawing. But, you know, to note on the back, like these distances to the 2 sides are not equal. So you can tell which lead is 1 and which is 2. Okay, so I'm gonna leave that like that for now, because I'm gonna test the other transistor first. So I am testing right now, I am testing this column right here. Okay, so I'll leave the pen there so you know that we're testing this column on this transistor here. And we've got leads 1, 2, and 3. So I'm going to go through and make the measurements. You can see the meter there, and you can note down the readings. Again, we'll get our good friend, the narwhal tape, just to try and hold down this transistor. I could, I suppose, put it into a breadboard or such, but I don't really want to, because I don't want to introduce another possible source of error by introducing wires and breadboard holes into the mix. Okay, so there I have my transistor. The top leg there is 1, middle is 2, bottom is 3. It might be hard to see because you're getting a bit of shadow on the page there, but I'll announce it anyway. And remember that, you know, the hint they've already given us for this one is that we already know that leg 2 is in fact the collector. So that's a bit of a hint. So I'm going to go lead 1 positive and lead 2 negative. And there's your result on the meter. Let me take that again one more time, just being a little bit more solid. There is 1 positive, 2 negative. Okay, and then I'm going to go 1 positive, 3 negative. Okay, there's 1 positive, 3 negative. And then I'm going to reverse my leads now, and I'm going to go 2 positive and 1 negative. So there's 2 positive, 1 negative. Hang on a sec, let me make sure my leads are solid here. Okay, there's 2 positive, 1 negative. And then 3 positive, 1 negative. Okay, and now we're going to do 2 positive, 3 negative. So there is 2 positive, 3 negative. And I'm going to reverse that. Here's 3 positive, hang on a sec, this is tricky. 3 positive, 2 negative right there. Okay. So those are your readings. Oh, my pen moved over. Those were your readings. I'm sorry. Those were your readings for this column, okay? The MJE 3055 is this one. So those are your readings for this column, okay? Now we're gonna do your readings for this column. Okay, so let me try to position my transistor a little bit better. Okay, so what I've done here is I've labeled the legs so that I can leave this transistor flat on the top of its case there. So remember, if I'm looking at it like this, like the picture, the leg closest to the page there is the one closest to me is the 2, and 3 is the case. When I flip that up like this, you can see that it's 2, 1, and 3 over here being the case. Okay, so that is what we're measuring right now. And just to keep in mind that we're on this part of the table, I'll pick something smaller. It is the Lego figure that is going to tell us that we are doing the first column of this table. Okay, so we're doing this column. All right, first column. So let's take those measurements. We are going to go 1 positive, 2 negative, and you watch the meter. So there is, actually, hang on, let me tape down the transistor too. Okay, so 1 positive and 2 negative, there is your reading. 1 positive and 2 negative. Okay, and then I'm going to leave 1 positive, and there's 1 positive, 2 negative. Then I'm going to go 1 positive, 3 negative. Now I've got 1 positive, 3 negative. Okay, and then I'm going to go 2 positive and 1 negative. There's 2 positive and 1 negative. Now I'm going to go to the case. There's 3 positive, 1 negative. 3 positive, 1 negative. And then I'm going to go 2 positive, 3 negative. 2 positive, 3 negative. And now I'm going to go 3 positive, 2 negative. There's 3 positive, 2 negative. Okay, so you've got your readings from these 2 transistors now. What you need to do is identify by writing on your lab sheet which pins are collector, base, and emitter for these 2 transistors. Okay, and you're doing that by looking at the table of readings that you would have filled in. And remember that that table that I was filling in is not included in your lab sheet. I just made it for myself. You can, on a little piece of paper, draw yourself a little table and write in the readings that we took there, and then base your decision on what those readings are. Okay, so that gets you through part A of lab 6, which is procedure steps 1 to 4.